Welcome to this session. In this session, we are going to find the solution to the Fibonacci sequence, whose initial condition are specified to be f0 to be 0 and f1 is 1. So solution. So we'll assume that the solution to this sequence is r power n. Let f sub n be r power n, where r is non-zero, be the solution. Let me call this one 1 to 1. So when you say fn equals to r raised power n, it implies that fn sub n minus 1 will be r raised power n minus 1, and fn minus 2 is r raised power n minus 2. So let me call this one 2. Now what you do, you replace this, and this one into the equation 1. So equation 1 becomes r power n equals to r raised power n minus 1 plus r raised power n minus 2 by simply substituting these values for fi's. Now, since r is not 0, then we are allowed to divide this equation by r raised power n minus 2. So divide this one by r raised power n minus 2, r raised power n minus 2, r raised power n minus 2. If you do that, then we get r squared equals to r plus 1. And on rearranging this quadratic equation, we'll have r squared minus r minus 1 equals to 0. Now we use quadratic formula to solve for r. This is what we call the characteristic equation. So r will be given by minus b, so minus 1 is, and then minus 1 squared minus 4 times 1 times negative 1 divided by 2a, and a is 1. So this will be 1 plus or minus square root of 1. Minus 4 times minus 1 is plus 4 divided by 2. So r will be 1 plus or minus 1 plus 4 is 5 divided by 2, i.e. r1 is 1 plus root 5 over 2, and r2 is 1 minus root 5 over 2. So these are case of two distinct roots. And once we get the roots, we write the general solution. So therefore, the general solution of equation 1 is f sub n is c1 r1 power n plus c2 r2 power n, which is the same as c1 1 plus root 5 over 2 power n plus c2 1 minus root 5 divided by 2 raised power n. But because we are given the initial condition, then we can find particular solution for this given equation to find C1 and C2. So given that f naught is given by 0, then it implies that C1, 1 plus root 5 over 2 raised power 0 plus C2, 1 minus root 5 over 2 raised power 0 is 1, and any non-zero number raised by power 0 is 1. So this will be C1 plus C2 is equals to 1. So call this one equation 3, and F1 is given as 1. So this implies C1, 1 plus root 5 over 2 raised power 1 plus C2, 1 minus root 5 over 2 raised power 1 should give me 1. This is 0, not 1. So F naught is 0. So correct that. So any number raised to 1 is the same number. So this is the same as C1 and then this can be written as a half plus root 5 over 2 plus C2 into 1 over 2 minus root 5 over 2 equals to 1. Call this one equation 4. Now from equation 1, C1 equals to minus C2. So where there's C1, I can replace by C minus C2. So which means this will be minus C2 into 1 over 2 plus root 5 over 2 plus C2 into a half minus root 5 over 2 equals to 1. So let me open. I'll have negative a half C2 minus root 5 over 2 C2 plus a half C2 minus root 5 over 2 C2 equals to 1. And this and this cancels out. So minus will be 2 of them. So minus root 5 over 2 minus 5 over 2 is be just simply minus root 5. C2 will be 1. So which tells us that C2 alone will be negative 1 over root 5. So which implies C1 will be positive 1 over root 5. The same can be written as negative root 5 over 5. This can be written as root 5 over 5, simply rationalizing the denominator. So therefore, the particular solution is Fn. So C1 is root 5 over 5 into 1 plus root 5 divided by 2 power n. This other one is negative, so negative root 5 over 2 into 1 minus root 5 divided by 2 power n. So that is this. This is 5 not 2. So that is the particular solution to that given problem. Thank you.